Imagine you're below deck on a ship. No windows, no engine noise, just you, a bowl of fish, some butterflies, and a bottle slowly dripping water. Now, are you moving? That was the question Galileo Galilei posed in 1632, and the answer? You simply cannot tell. For centuries, the dominant view, rooted in Aristotle, held that rest was the natural state of things, that stillness was fundamental, that motion was something added on top. Galileo threw that idea overboard. He argued that motion isn't absolute, it's relative. If your ship is gliding at a steady, constant speed, everything inside shares that motion. The water drops fall straight down, the butterflies float effortlessly, the fish swim without effort. Nothing gives away the fact that you're moving at all. There is no experiment you could perform in that sealed cabin, none, that would tell you whether you're drifting through open water or sitting still in a harbor. This was radical, because it meant there is no such thing as absolute rest, no privileged vantage point from which the universe measures motion. Your state of motion is only ever meaningful relative to something else. Galileo had just planted a seed that would grow, centuries later, into one of the most profound revisions of reality the world has ever seen. So Galileo gave us the intuition. Now let's give it teeth. Galilean relativity isn't just a philosophical idea about sailors and ships. It has precise mathematical structure. Formally, it says the laws of mechanics are invariant under the Galilean group of transformations. Let's unpack that. In classical mechanics, two things are treated as absolute. First, time. The interval between two events, say a flash of lightning and a clap of thunder, is the same for every observer. Second, distance. The spatial separation between two simultaneous events is also the same for everyone. These aren't assumptions we chose casually. They're baked into a four-dimensional space-time structure. Now, imagine two inertial frames. Call them S and S prime. S prime is moving at constant velocity, v, relative to S, and their origins coincide at t equals 0. The Galilean transformation is almost disarmingly simple. T prime equals t. Time is the same everywhere. X prime equals x minus vt. You just subtract where the other frame has drifted. Take the derivative, that's your velocity addition rule. U prime equals u minus v. If you're on a train moving at 30 meters per second and you throw a ball forward at 10, someone on the platform sees it at 40. Intuitive. Elegant. Here's the key insight. Differentiate again, and since v is constant, the acceleration doesn't change. A prime equals a. Mass doesn't change either. So when you apply Newton's second law, F equals ma, it looks identical in every inertial frame. No mechanical experiment, none, can tell you whether you're at rest or moving at constant velocity. Algebraically, these transformations, rotations, spatial and time translations, and what physicists call boosts, form a group, the 10-parameter Galilean group. And Galilean relativity is simply the demand that the laws of physics be invariant under all of them. Now, here's where it gets extraordinary. Einstein didn't throw this away. He kept the principle that the laws of physics are the same in every inertial frame, but he swapped the Galilean transformation for the Lorentz transformation. The difference? In Einstein's universe, the speed of light is constant for every observer, which means Galilean velocity addition breaks down at relativistic speeds. And it didn't stop there. In quantum field theory, the symmetry deepens further. The Poincaré group, the relativistic descendant of the Galilean group, becomes a foundational pillar of how nature works at its most fundamental level. So that insight Galileo had, standing on a docked ship in the 17th century, realizing that uniform motion leaves no trace in the laws of physics, that same insight runs, unbroken, through Newtonian mechanics, through Einstein's relativity, through the quantum fields that underpin all of reality. Not bad for a man who never left Italy.